Hi everyone, and thank you for joining our webinar with Schneider Electric on smart motor management solutions and how they can increase plants' efficiency and productivity. We're just gonna give it a few minutes to let more people join, then we will start. Perfect. For those who just joined us, welcome to our webinar with Schneider Electric on smart motor management. My name is Wiem Milky. I'm the marketing coordinator at Rexel. Our guest speaker from Schneider Electric is Chiu, offer marketing manager, who will be introducing himself shortly. Please note that this is a recorded webinar and will be available to watch on demand on our Rexel website. If you have any questions throughout the webinar, please feel free to pop them in the Q&A box and we will answer them at the very end. Now passing over to Sean from Schneider Electric.
Hello everyone, this is Sean Chiu. I'm the offer marketing manager in Schneider to look after the thesis, the motor controls. So today I'm very happy to be part of the presenter for the smart motor management, that what we can bring value to the customers from Schneider Electric. So let's move on. So thesis, I think, is a very well-known brand in the market for the motor controls. So from the legacy Tandem Mechanics to now Schneider Electric, thesis is always the best choice from the customers for the core motor control, with the contactors, with the motor circuit breakers, with the overload protections. So what thesis is, that this is the overview for the whole thesis family that we have for the motor management. So we from the very basic switch disconnectors, to the field switch disconnectors with the fuse protections for the short circuit protections, to the fuse carrier, encoder starters, and also the circuit breakers. So for the motor circuit breakers, we have magnetic and thermomagnetic, and then this is the well-known brand in the market. What we say is the thesis GV and thesis Deca for the contactors. So maybe you are already aware of that for the LC1D contactors, which is very well recognized in the market for the control of the motors. And also the control relay, the overload relay, overload overcurrent protections. And we also have a very compact size motor starters, what we call the thesis H, which is a small size. We can save you the size of the compartment and then actually save you the space. And also very good offers, very good products for an integrated motor starters. So basically we call the thesis U. And you may be aware of that. That is integrate the motor circuit breakers and then the contactors and the overload relay together. So it is a one combined solutions, integrated solutions to the customers, and also communicate to the system. Besides that, we also have a smart motor management system, which is we call the intelligence MCC overload relay. We call it thesis T, and also a digital load management solution with thesis Island. So today I will more focus on the thesis Island, which is an innovative and then the digital load management solutions, and how we can run the site, how we can run the motors in a smart way. So thesis Island, it is an innovative digital and smart load management. So basically nowadays we are not just using the contactors to control the motors on and off. And then what we can have is a much more and more data we can have, and then feedback to the system for analysis and for diagnostic. So what is thesis Island? Thesis Island, basically you see here is a contactors. It's just a contactors, not really. because we have a PCB board inside, so we basically to measure the current, and we can have all of the data for the motors and then can feed back to the system. So it is a data provider for a high machine efficiency. Let's say we can get the relevant data for the digital load management. We can also monitor the energy at a low level. So it is not a overall consumptions for the panels. It is a individual load energy that you can have this energy data for each individual load, means the individual motors, so that you can identify the performance or the energy consumptions of each individual load. It is also a service enabler, so you can use the load data and status to create a new business model. Because you have the data, you know the performance, you know the trip lot, or you know everything for the motor. So you can build a service business, you can build a lot of different business model with this data. And then you can access your machine from a remote during the operation and maintenance. Let's say for the trip, in the past, you may need to go to the site manually to turn on the motors again. But with these connections, what we call the connected offers, you can do it remotely. And then, of course, I think for all the connected offers, cybersecurity is one of the key topics we have to focus. So it is also benefit for the higher cybersecurity and safety levels. It is also actually faster to the market with the TCS Island because actually make your machine intelligence and object oriented with the avatar. So all the avatar you can imagine is something like the function block, and you can clone the function block very easily because it's all well predefined inside the product. You save time and cost for the commissioning because for the basic applications or basic pump applications, you no need to have a PLC to program it. You just need to configure it on the TCS Island, and you can actually achieve the autonomous control. We will talk about that more later. And then you also save cost for the wiring. You will see that actually the wiring is very simple. You no need to have additional wiring on the connections to the breakers or to the load. So all the wiring is fabricated into this module. You will see the ribbon cable to be connected and save time for the commissioning. And so this is the general overview for the TCS Island. And then what it is. So TCS Island is a load management up to 80 amps. So everything of the motors which is below 37 kilowatts, you can use the TCS Island to control. So we basically have different motors or different starters. We have the contactor inside, so we control the motors with the contactors. And then every single starter is connected to the screen part, what we call is a bus coupler. So this bus coupler will gather all the information internally with this ribbon cable and then communicate to the system or to the PLC while the Ethernet IP, Modbus TCP, or the Profilex bus. So everything is connected to the over the Ethernet. And then one bus coupler you can equip with maximum of 20 starters. And then you may ask, how about if my applications is more than that? It's more than 20 starters. No worries, because you can have a second bus coupler to control or to communicate with another 20 starters. And then you can just actually connect 2 islands or even 3 islands or more with the Ethernet daisy chain. So everything can be connected through the Ethernet network, and then you can access all the data for the starters. There is no auxiliary wiring necessary because all the status of the contactors, the status of the motors is already communicate or gather the information to the bus coupler. And then you can just have the data for the status of the contactors with these communications. So no need for the auxiliary wiring, no auxiliary contact block. So you can have all the status of the motors. And then the digital and analog I/O is also available. You will see that we have a analog modules with have a 2 input and 1 output. And then I also have a digital modules for 4 input and 2 outputs that you can have all the sensors input to the system to set a different threshold for the alarming or to do the autonomous control. So all the analog signals or digital signals can feed back to the system, and then you can do what you want to do. So, and then the reference, in terms of the reference level, is very simple. We only have about 21 references. So it's keep it simple for the customers for the selections or configurations. So as we mentioned, all the starters or the AI modules or the digital module will be connected to the bus coupler. We have 4 different protocols for the bus coupler to communicate. So we can communicate through the Ethernet IP and the Modbus TCP, which is the common protocol in the market, I would say. But if actually the system is using Profinet or Profibus, no worries. We also have these other part numbers for the bus couplers to communicate with the Profinet and Profibus. They are, I mean, the same in the outlook, but with different part numbers to communicate with different field bus connections. And then in terms of the starters, you will see that so one bus coupler we can communicate to maximum on 20 starters. And then we will do some basic survey before that. So most of the applications is about 5 to 20 starters. So you will see that actually this is fulfill most of the requirement of the in the market. But as we mentioned, if it is more than 20 starters, no worries, that you can have a second island or third island. In terms of the starters of the module, it's very simple that we only have 1, 2, 3, 4, 5 different references to for the different applications. So 9, if you're familiar with the LC1D reference from Schneider, so we have LC1D 09, LC1D 25, LC1D 38. They are the same. Now the 9 means 9M. 25M, 38M, and up to 80M. So everything for the motors which is below 37 kilowatts can be used in this island as a control. So it is a starter. So it is a contactor. So basically the width, the footprint is same of the TCSD LC1D contactors, and all the accessory like the bar coupling or all the other accessory we can use in the TCS island as well. So the TCS island inside is a contactors, it's an LC1D contactors, but with a PCB board inside. So with this PCB board, we can measure the current, we can gather all the data for the motor for the system, and then we can also have overload protections inside the TCS island. So with the TCS island, you no need to consider about the overload relay or the overcurrent protections because it's already built in inside the TCS island. And then we have the digital modules and analog modules, so you can have different input temperature sensors, temperatures, humidity, or others, let's say the flow sensors or pressure sensors. You can also, I mean, for those information to fit into the system for the control or for the monitoring. And this is we also equip with the voltage interface module that we measure the actual voltage. So basically, we measure the actual voltage for the system. We are not assuming the system voltage is 230 or 220. We measure the actual voltage. And then with the actual voltage, we also measure the actual current of each individual starters, of each individual contactors. That means now we have the actual voltage, we have the actual current, so that's why we can have the actual energy consumptions of the individual load. So it is not assuming the voltage is 230 and then by calculations on the energy consumption. It is something like the other manufacturer is doing that way. But for us, we are measuring the real voltage and current to have the actual energy consumptions of the individual load. So this is all the data we can have for the TCS island. So TCS island is as a data provider. So not just the current. You will see that we can also have a health data, the time device on, the switch on, number of faults, and then utilization category, duty cycle, switching cycle, maximum current, average current. So this is all the health data we can have in the TCS island without any additional modules. So everything is already ready in the bus coupler, and then you just set the bus coupler through the Ethernet, and then you can have all this data. And also we can have the product identification data, the vendor name, the product code, the product name that you can set in the system. For the energy data, you can have the power data, demand parameters, energy data, time of use. This is all ready for you to have it. And for the upstream protection, so we still have need to have a circuit breakers to protect the system. But as I know, as I said, that because the overload protections is already built in the TCS Island. So what you need to consider is only for the short circuit protection for the circuit breakers. You no need to consider about the thermomagnetic one. So you only need to consider about the magnetic one for the short circuit protections. And then for this upstream protection, you can have the current phase loss, current mismatch, phase mismatch, phase reverse. So all these upstream protection data you can also have for the inside the bus coupler. For the motor protections, even for the thermal overload, for the motor overload, and then for the undercurrent, overcurrent, motor jam, long start, motor store, or the cycle, you can also actually have all these informations. And then when the contactors is tripped, and then you can also have alarm, and you can actually have some alarming before the failure. So we will talk more about that later. So in terms of the physical size of the inside the panel, you will see that before and after. So before, I mean, equipped with the TCS Island, you will see that we need a lot of contactors here for the overload protections, a lot of wiring, and then you will have a power meters to measure the energy for the panels. But this energy is only for the whole panel. It's not for the individual motors here. And then you also need some I/O card, I/O interface to the PLC, and a lot of wiring need to be considered here. But with the TCS Island on the right hand side, then you will see everything is very tidy, and then no power meters is needed because we have already measured the energy for each individual load. Low I/O interface module to the PLC is needed because we have the AI modules, we have the digital modules that you can have all the data into the system and then to the PLC. And then to the PLC, very simple, just one Ethernet cable to the PLC, and then you can communicate to the PLC system. And then each TCS Island, they will have a dedicated IP address. So for the PLC, just simply access or the receive this IP address, and then because this is a Modbus protocol, Ethernet protocol, so the register is open. So you can actually, we have the register table, which data you would like to get from the from TCS Island to the PLC. So you just actually according to the register table, and then you can have all the data. Okay. So this is in terms of the hardware for the TCS Island. So what about the value propositions for the TCS Island compared with the conventional motor starting? So this is the value propositions for the TCS Island, that we can bring more value to the customers, not just turn on and turn off the motors, but with more. So what's that? So we can, summarize for 6 different key values for the TCS Island. So first is the virtual sensors. What does it mean? Because we monitor the current of these individual motors. So by monitor the current, basically you can estimate the temperature change or the pressure of the system. So because if the temperature of the motor is going higher and higher, the current will go high as well. It's actually, this is a the relationship between the temperatures and then the current. So when the motor is much more hotter, then sometimes actually the overload is being occurred in the motor. So the current will go high as well. So by monitor the change of the current, you can estimate the temperature of the motors. So this is what we call the virtual sensors. You know that you have an actual sensors installed in the motor. So let's say for a very legacy installations for the at the site, basically do not have the PT100 temperature sensors installed in the motors. But with this island, even though it's difficult for you to install a temperature sensor or to retrofit the motors installations, you still can using the TCS island by monitor the current to estimate the change of the temperature of the motors. So this is what we call the temperatures the virtual sensors, because we have analog modules, we have digital modules, so you can actually input all the sensors signals to the system. Second is the energy consumptions. So we emphasized this before, that we have the individual energy consumptions of the load. That means we can identify the efficiency of each different motors. So what is the benefit to the customer is we can optimize the consumption of the machine for better performance. So that means now, for example, I have 6 different motors, and then I understand the performance and efficiency of each different motors, then I can shift the load from the less efficiency one to the most efficiency one. So this is actually one of the benefit that we can bring to the customers if we can understand the energy consumptions of each individual motors. And also by the monitor the energy usage of each equipment, and then we can actually do better use of electricity with a better tariff rate with the load shedding. So especially for this energy crisis that we're facing. So actually we can understand the, for example, this motor is using more electricity, that we can shift off the motors, or you can shift more load to the other ones. So you can actually to save your energy. And then you can also monitor the trend of energy for different seasons, so you can actually rescale your production size, and then with the peak or off-peak season. So all can be achieved, without the data. If we do not have the data, if we do not have the energy data, you cannot achieve this all the values. So the energy consumption is very important, or very critical to the customers, especially for this energy crisis. The third is to increase the machine uptimes. So in the other words, is to reduce the unexpected downtime. How we can achieve this? Because in the TCS island, in the system, we can set different thresholds, and then we can send out the alarm or the alert to the operator something is happening. Let's say, for example, the current is already over 80% of the threshold of the flow current. At the same time, the temperature is going higher. And then if you have a temperature sensors on the motors, the temperature is going up to maybe 60 degrees or 70 degrees, then something may happen. So the system is still run very well, no problem. But you will foresee that, okay, maybe something happens for the system. Maybe actually there's a failure will be occur in the future. So before the unexpected downtime for the motor, before the failure, you can have the notifications to operators. Okay, the current is too high now, the temperature is too high now, and then you have to schedule some of the routine maintenance to the motor. You have to schedule the downtime to inspect the motors, to inspect the system. So you can plan your downtime, and then you can plan your spare part, unless basically if it is unexpected downtime suddenly, then actually cost you too much. You have to buy your spare parts for the replacement. You have to allocate your technicians resources to the site immediately. It will cost you too much. So this is what we call the increase the machine uptime, because you can understand what is happening before the failure. And then it's also a data provider for the diagnostic, for the advanced diagnostic. So it's allow more data transfer, and then system comes to its full potential if you start to use the power management. So we have all the data, we provide the data. With this data, you can have an analysis on what is happening on the system. And then the user don't need to worry about the extra cost for the additional equipment for measurements, because with the TCS Island, with this smart motor management system, all the data is already available. No need to consider about the additional equipment, such as the power meters or the other equipment to have the data. And then the advanced diagnostics function also help to detect the failure of the internal device. So we will actually have different comparisons on the, okay, maybe the flow of the water is too high, and then for the current is too high, and then you can actually to identify what's happening for the system. The fifth is autonomous control without a PLC. This is something very interesting that we will talk more about later. So within the TSIS island, you can actually set autonomous control in the TSIS island without the control for the PLC. Let's say for typical pump applications, you will basically, for a basic applications, if the water tank, the water is lower than a certain level, the motor should be kicked off. Okay, and then if the water levels is higher than a certain level, the motor should be stopped. So in the past, we need to have a small PLC to have a very simple program for a PLC to control the contactors, to switch on and switch off the motor to achieve that basic applications. But with the TSIS island, we can configure it inside the bus coupler. So because we have different sensors input to the system, you can set different parameters for the sensors. And then when these parameters is going to a certain level, you can kick off and stop the pump automatically. So without the PLC, so for a typical small and medium-sized pump applications or other applications, you can basically save the space and cost of the PLC. Because the TSIS island, you can achieve this autonomous control without the PLC. So we will talk about that more later. So you can save the cost for the PLC and also save the time for the programming for the PLC. And then the last but not least is the open connectivity, because the TSIS island we are using, if you remember, we are communicating the system with the Profinet, Modbus, Ethernet, Profit bus, which is all the open connectivity. So this is not a proprietary system of Schneider, even though your existing system is using Siemens or ABB or Rockwell, doesn't matter, because we are not a proprietary protocol or proprietary system to Schneider, so we can communicate to other external parties. So even though you are using other manufacturers' control system, no worries, because we can communicate to that system and then use the TSIS island to have this achieve this all the values to the customers. Okay, so this is the key values for the TSIS island, and then how we can use the TSIS island or this intelligence motor management system to respond the list of today and tomorrow applications. So here we go. So what can we do different with and without TSIS island? So in the past, or even that what we do now, what we do today, we are using a typical configuration for the motor circuit breakers and with the contactors and to control the motor. So we can only basically to have a status, chip status or the on-off status to the PLC, but there is no fault differentiations. There is no individual analog setting. There is no energy consumptions that you can have for these individual motors. There is low alarm, low reset at distance, low current voltage measurement, no power monitoring, and no lifetime information. The only information you can have is only the status of the contactors with the auxiliary contact block. So this is what we do today. So there's a lot of I/O wiring, a lot of couple control vials, and then this is what we do today. But what we could do to improve the system or to make it more smart or intelligent is to replace the existing contactors to the TSIS island, and then no status contact is needed. So as I mentioned, there's no auxiliary contact block is needed because all the status is already here in the bus coupler, and then you can communicate to the system. And then we basically monitor the presence and the quality of the supply side. So even though for the supply side there's lots of power, we understand, we know that because we have the monitoring on the supply side, on the quality and the power presence. We have the alarm for all possible faults. So you can have a different fault alarm to send to the operators before the failure. We have the full accurate digital setting. We have the low consumptions electronic protections and coil. You can remote reset for all the faults. Of course, you have to enumerate the faults, but you can remote reset for all the faults. We have the full voltage measurements, full current measurements, full energy monitoring, and then this is open communicate to everywhere. So this is that what we could do more, and then to upgrade our system to a smart system. So how we can do that? And then before we talk about that, you can also basically use the Disease Island not only just for the motors. You can use the Disease Island to monitor all of the other load. So we have another what we call the modules, not just a starters. We can actually have a PCB board. We can have we call the power interface module, that you can use this module to monitor the lighting system, the heating system, the battery loading. So basically, this is not just control the motors. It's not just monitor the status of the motors. You can also use the Disease Island to monitor the energy or to monitor the status of the other load, like the lighting, heater, and then the battery loading. So this is actually not just for the motor management, for a while lower management. So how we can upgrade the existing or the current install base or for maintenance and repair if now we are using the conventional contactors. So imagine this is the conventional one, that in the existing panels, you have the circuit breakers for the short circuit protections, and you have the contactors to drive the motors. And then you can just actually to use the power interface module, if you like, that this is a PCB board. This is actually can monitor all the data from the motors without changing the contactors. So you can just actually use this power interface module, and then you can have all the energy monitoring with the voltage module. Then you can achieve all the benefits or value that we talked before. So it's simply very simple that using the existing panels, and then you can upgrade the existing panels to achieve those values that we talked before without changing the contactors, without changing the whole system. And with the Disease Island, and we can have two different approaches for the local manual control and remote control. First, for the local manual control, so because we communicate to the system, we communicate to the PLC. Even though without a PLC, you can still using the bus coupler and then to monitor all the status with the HMI. So this is what we call the local manual control. With the data visualizations, you can visualize all the data into HMI. Or even though for the Disease Island, each bus coupler, we will have a web page, embedded web page in the bus coupler. So you can use your computer to connect to the bus coupler and then open the web page, input the specific IP address, and then you can go to the web page, what we call the operation and maintenance menu, and you can have all the energy data, and then you can control locally with this web page. So all the bus coupler is embedded with a web page of the Disease Island. So you can switch in all the other protection function, the digital alarm, the lifetime monitoring, current measuring with the HMI. So this is the local control. If you don't want to communicate the system to the the contactor to the system, or you can achieve with the remote monitoring and remote analysis. As I mentioned, this is basically communicate with an open protocol. So you can communicate to the PLC, you can communicate to the even for the power SCADA, then you can visit the bus coupler for the remote monitoring. So all the data can be remote monitor in your dashboards, or you can remote control the on-off of the contactors, the status. So you can achieve the local monitoring, the local setting, the manual control, or even remotely. So this is basically you can just sit in front of the computer in the office and something happened, and then if the fault is occurred, the fault is actually is come out, then you can actually reset the system remotely in your office, and then you know to go to the site. And with the system, we also have the I/O modules. So now we have the I/O optimizations. What it means that because we can utilize these I/O modules to send the signal to a tower light, to a pilot lights for the on/off of the motors, if you like, on the panel. So you no need to have another I/O modules from the system, from the TCS island, from the contactors, and then to send the signal to the power lights, or the signal lights for the on and off status. So now you can use the I/O modules which is already provided with the TCS island, and then to optimize this I/O module to control and to monitor the status of these contactors. And also very important is, I don't know whether you know about the I/O card, the I/O distribution card for the PLC now is in shortages situations, not only for us, I think it's for other manufacturers. So now the lead time is very, very long for the I/O card of the PLC. And then the TCS island with the I/O modules, you can take this as an alternative for the I/O card to the PLC. So let's say forget about the starters. You no need to have a starters. You no need to have a other component. But with the I/O modules and then the bus coupler, and then you can take this as a I/O card for the PLC because it is communicate with the open protocol. And then the lead time for the TCS island now is only about 46 weeks. It's not too long, but compare with other I/O card or I/O distribution module for PLC is count on months. So basically, this is a possible alternative that using the TCS island as an I/O modules for the PLC communications. And also, we also provide the safety circuit or the starters for the system. So we also have a reference for the safety starters if you had to achieve the seal level and seal 1, the safety switch category 1 or category 2 or category 3 or 4 for the redundancy on the safety circuit. So we also actually have a safety interface module to equip with the safety starters together for the safety level, for the safety group switch, and then also for the e-stop and then for the safety relay. So it's all already ready for the safety circuit as well. So you can achieve different category with different configurations, or a standard started or the safety started. Okay, so I think we talked about this before on the autonomous control based on the positive variable. So let us talk more details on that. So we have, this is very interesting for the autonomous control, that you no need to have a PLC for such a control for the pump applications, and then you can all achieve with the TCS island only. So let's say we measure the positive variables for the level sensors or the control system. The values for this process variable is continuous monitor. So that's when we can control the system, the motor on and off based on these variables. So we monitor the fluid level from the sensors, and then these levels, the fluid levels signal will go input to the system, to the TCS island, or you can also measure the coolant temperatures with the different sensor signal input to the TCS island, input to the system. And then by monitoring the fluid level sensors, as I mentioned before, if the fluid level is too low, the pump should be kicked off automatically. And then if the fluid level is too high, the pump should stop. And then this all can be configured inside the TCS island. So what we call the configure, we are not programming because we are not using the ladder program for the PLC. No need to program in the TCS island. You just need to configure with the selection table. So it's very easy, and all the configuration software is free. It's free of charge. Actually, it's free to download in our website, and then you can just go to the software and then you configure it with a different selection table. Okay, these positive variables when the fluid level is too high, or you can actually input different ultrasonic sensors. And if it's too high, then you can stop the pump. If this is too low, then you can kick off the pump, and then it can be achieved automatically inside the digital island without the PLC. So this is what we call the autonomous control, and it may benefits to this customers, especially for the OEMs or the small and medium-sized pump panel builders. So because you no need to have a PLC to control the system. So same actually what we talk about, the we monitor the fluid level, or we monitor the coolant temperatures, that you can based on these variables to control the motor automatically, and then you can just need to configure the setting in the designer. Okay, so this is all the values in terms of hardware, in terms of applications, and the values that we can have the Jesus Island. So what comes next? So this is coming very soon, that for the Jesus Island, we also consider about the predictive maintenance of the motors. So what this means, let me talk more about that. So maybe you're all very familiar with the maintenance cycle or maintenance type, that we have a reactive maintenance. Okay, something happened, that we go to the repair. Preventive, we prevent the preventive maintenance. We schedule maybe 1 month. We have a routine inspections, maintenance to the equipment. So we actually what we call it preventive maintenance. What we can do more is predictive. We can predict something happen very soon. Then so we can basically plan our downtime, to plan our schedule, to plan our resources to the maintenance. So for the thesis island, what's coming next, that we will have the thesis predict module, that we can predict that for the motors something is happening or something is going wrong, and then you can schedule your downtime for the inspections. How we can do that? This is the technology that we use called the model-based voltage and current. So if you heard about that, there's a lot of different predictive maintenance or predictive technology for the motors in the market. Let's say some company, they are using the vibration analysis. They measure the vibrations for the motors. So you have a vibration sensors on the shaft, and then on the housing, then you measure the vibration for the motors, then you can identify maybe the bearing issues, maybe the misalignment of the motor to the pump, or others motor failure. But our technology is using the model-based voltage and current. What it means that we measure the voltage, and then this voltage will have different disturbance. And then by the measuring this voltage to a frequency transform to different spectrum, then we can identify something happen with this specific spectrum. So by using the monitor the voltage, the disturbance for the voltage, then we can understand something happen or the failure of the motors. Of course, actually different algorithm requirements. So for this island, we actually offer the lowest offers for the B1, but it's already enough for us to identify the basic failures for the motors. So the idea is we measure the voltage, then we do some residual currents analysis, we transform to different spectrum, then we identify the failure of the motors. And then we can also actually have the different status. So we can have a red light, yellow light, green light to let you know, okay, this is in good conditions or not, or you have to send someone to inspect. So this is the failure that we can identify with this technology. So the motor fault, the foundation loosen, the unbalance, the rotor bar cracking, the stator problems, the motor bearing problems, or even for the misalignments and belt drive problems. So all this is a mechanical failure for the motors in the system. And then we can, based on this technology with the TCS Island, with the additional modules that we can identify. So it will come soon, not today, but I would say it's by the end of the year. So, but it's good to know that we will actually moving forward to much more intelligent and smart to control your system. Okay. So this is all the TCS Island, and then if we only have one slice, and then if you only have 5 minutes or even less in front of customers, how you can help customers about TCS Island, how you can tell customers what the benefit that we can bring to you. So here you go. So this is one slice tells you what TCS Island is, and then what's the benefit to the customers that we can bring to them. So this slide deck I will share to you after this session, so no worries. So this slide, in this left hand side, we talk about the hardware. So we have bus coupler. So it's clearly identified that this is a bus coupler. We have the analog modules. We talked about that before. We have the digital module. We have the voltage interface module to monitor the voltage. We have the power interface module for the load monitoring, not just the motors. We have the standard starters and this safety level interface module. So this is all related to the hardware. And on the right-hand side, what the TCS Island is targeting in different segment and channels. So it's targeting on the waste and wastewater, packaging, food and beverage industry, but not just that. As I mentioned, this is actually is intelligent system, intelligent contactors, intelligent motor management system that you can use in different segments or even in all the segments. And then in terms of channel, of course, for the OEMs, the integrator, the MCC panel builders, so all, especially for the end users, that actually you can apply. What is the key value for the TCS Island? So the 6 key values that we have talked before is already mentioned here. So virtual sensors, energy consumptions, energy monitoring, to increase uptime, data provider, autonomous control, or the open connectivities. So this one slide tells you the hardware, the go-to-market, the segment that we target, and also the value that we can bring to customers. If you only have 5 minutes in front of customers, you can use this one and then to bring the value. Okay, this is something that we do different with the others manufacturers or the others operations. This is something that we do different because nowadays we are using the advanced technology to make you want the motors, make you want the system more smart. So that's all for me today. And then I hope you have ideas on the technologies of the motor management nowadays, not just the contactors to switch on and switch off the motors, that we can have a lot of different data we can have and then to benefit to the customers. Thank you so much. And then let us go to the Q&A sessions.
Thank you so much, Sean, for these great insights. For now, we don't have any questions. I think you've covered everything, but if you have any other questions or thoughts about the topic or the product, please don't hesitate to reach out to us at marketing@rexel.co.uk. So yeah, if you don't have any questions in a few minutes, maybe we can finish our webinar. So thank you everyone for joining us today. I would like to remind you that we have a big Schneider Electric promotion going on with Rexel. It's called Make Memories. If you have a minimum spend of £50+ and you can win hundreds and hundreds of prizes, experiences and holidays. So for more information, get in touch with us, check out our Make Memories page, go to the branches, check out the products and the promotion. And we look forward to having you in our next webinars. Thank you so much again, Sean. And if you have any questions, we will follow up with them by email separately. And we will be sending everyone the presentation from today. So have a good day. Have a nice weekend, everyone. Thank you.
Thank you so much.
Bye.
Bye.